Okay, in the previous class, we saw what is road to autonomous vehicle, advantage, all those things, correct? As we told that the automated highway system platooning concept, having a special road, all those things has been tried around the world, starting from path program, Berkeley University, Japanese, European tow bar, correct? We know that Schaffner program in Europe, electronic tow bar, all these things are tried, platooning, all those things. But of course, the this program, CHAFIA, correct, which is called European Electronic Tow Bar, it doesn't need a special road. It's regular road, but with this ADAS, correct, ADAS, and the front vehicle driven by driver. Other vehicles are just following. Of course, there are drivers inside the vehicle. They are taking risks whenever they want. They can change the road, lead. Correct. This is the lead. Others are following. Lead road will be changed every 4 hours, something like that, within the driver. They talk with each other. It doesn't happen automatically. It is a manual control, correct? Taking over is done by manual control, but the front vehicle always driven by a driver. That is this program specific, correct? Electronic tow bar. The front vehicle driven by human driver, correct? It has a radar, ADAS, all those things, obstacle avoidance, camera, lane following, everything. Assistive systems are there, and it can also do automatically following the lead vehicle. But that's what we saw, correct? So due to this, what is advantage we can see, correct? Connected vehicle technology, connected vehicle technology. The main benefit is almost same as what we have discussed earlier. I will quickly go through. More vehicle can be accommodated, road density increases, even in connected vehicle technology, correct? The number of vehicle per lane has increased significantly. Passenger safety is increased because human error factor is mostly removed. But correct, in platooning, there are two types of platooning is there, correct? One is the AH, special roads with sensor. No vehicle is controlled by human. All the vehicle, including lead vehicle, following vehicle. Platooning means you have a lead vehicle, correct? You have a lead vehicle, correct? As I told you, they have a lead vehicle and there are followers, correct? So the vehicles are moving right to left, correct? This is the lead vehicle, correct? And this is follower 1, follower 2, follower 3. Nothing is physically connected. They are electronically connected by electronic tow bar. That's what we say, electronic tow bar. That means electronic control, they are maintaining this inter-vehicle better using LIDAR or radar or ultrasound sensor, ultrasonic sensor. Using that, they measure the distance, inter-vehicle distance, correct? Inter-vehicle distance, this is maintained depending upon the lead vehicle speed, correct? So everything is programmed, correct? Everything is programmed, and the lead vehicle is driven by human driver. Human driver in case of the Schaffner program, correct? This program, you can see that this is driven by a driver. Other vehicles are followers. This is lead. Other vehicles are followers. Correct? There are drivers, they are not driving. The vehicles are following using electronic control. Correct? This time all those things. So this is one thing. Another one is we saw that already the other one, correct? So path program. Correct? Already we talked it. I think it is appearing twice. The path programming also, platooning, correct? We demonstrated in the California State near Berkeley University. Special road, all those things already we saw in the previously, correct? So then the advantages are same, correct? So passenger safety is increased when it is autonomous driven. This in case of path programming, correct? Partners for this one automation, the program, which is a Berkeley University. Here, lead vehicle also driven by computer. After there are driver. Please note that whether Tesla car or any car, there is a driver. That is the rule. That's what today we are going to see. That is mandated by the government. Correct. So driver has to be there, steering, all the control should be there. But if in the emergency situation, then human driver should take over. Correct. All weather operation is possible. Mobility for all need. All those things are possible. Already we saw fuel consumption is reduced, emission is reduced because no frequent gear change, unwanted braking, start-stop operation, and low-speed operation, ideal condition. In traffic jam means vehicle will be running. They call ideal condition without gear. All those things significantly wasted fuel and also emission, lot of emission that is reduced. lanes can be more effectively used. We know that the inter-vehicle space can be reduced because all the vehicles are controlled. Then commercial operation, which we saw, correct? These are things possible. Then path towards road autonomous vehicle is very simple. Path toward road safety will begin with incremental automation, correct? Which is called as ADAS, correct? Advanced driver assistance system. Okay, special road is not possible. This is not. Then what is the best solution? Make your vehicle as a self-driving or autonomous driving without human intervention at all. That is the concept taken by Google, Tesla, all those things. From that is started in 2000. Till then, they were trying to have special road, all those things they tried. Around the world, US, Germany, everywhere they tried, then they said it's not possible. Correct? Land space is limited, all those things. So, correct? Inclusion of advanced safety features. What are the electronic stability control, blind spot detection, collision avoiding, lane shift warning. All these things have done in 2000, 2010. Correct? This is called as ADAS, Advanced Driver Assistance Systems. Short form is ADAS. Right? So this is all the human is driving, but this ladder, radar, camera, all this thing are used to find out obstacle, lane marking, road signs, all those things. If you deviate from the lane marking, it will vibrate, all those things. They assist the driver. Right? So that is first step. That is the first step.
હું 10 તારીખે કક્ષાના મારી સબ્જેક્ટ વગર વાંચી 10 તારીખથી જ રજા મૂકી હતી મારો દાખલ થવું પડ્યું ભરતભાઈના દવાખાનામાં
Hello, I'm in class. Okay. Okay. So advanced driving assistance. Advanced driving assistance, for that you need the sensors. Lot of sensors will be used. One minute. Okay, lot of sensors will be used for help the driver, correct? So advanced driving assistance capabilities, rear view cameras, additional, correct, emergency braking, correct? So it started from 2000 onwards, correct? So road to autonomous car, okay, that is self-driving car, which can be drive itself in any road, no special road, just like a human drive will do, correct? So advanced driver rear view camera, automatic emergency brakes, lane centering assistance, all started in 2010 to 2016. Since 2016 onwards, partial autonomy with features helping drivers to stay in the lane, adaptive cruise control, which is there very long time, self-parking, right? Which kind of vehicle can park. You can get down from the vehicle and push a button. It will find the empty space in the given parking lot. It will automatically park, self-parking. All those things came in most of the high-end cars. Right? These things are available only in high-end cars. Please know that they are available. High-end car means expensive, high-end cars. Right? From June 2011, Nevada state allowed the driverless car to be tested. That's why I told you Tesla car was Google tested initially. Correct? Google, then Tesla cars are being tested in the public road itself. In this one, now of course many states are allowed. Okay. So what is the future? Why we have to do this one? The future for the autonomous car? Because a lot of roadblocks are there. Roadblock means difficulties in implementing, correct? Making this driverless car, whether it can drive in everywhere in all the countries, all traffic condition. It is really a complex. We know that the autonomous car replacing a human driver is tougher. But people said it won't come at all in 2000. But now we said already Tesla is selling commercial cars. So what is the prediction? Prediction is by 2030, 95% US car miles already, I think previous car vehicle I told, more than 90% of US car miles, I am talking about this light vehicles, will be served by autonomous electric car. Already we saw that pollution avoidance system, and reducing demand for vehicle body repair reduce, because I told you the survey has happened, correct? Most of the vehicle will be electric vehicle, correct? So extensive skill is needed, but servicing electric vehicle needs special training, all those things. But electric car is going to be the predominant vehicle of future, passenger vehicles, especially cars. Maybe soon the trucks also will follow. Require network force, new workforce, correct? If I wanted to do the autonomous car, you need a new workforce. That means service engineers, correct? We know that right now you have service in a roadside service in India, Asian countries, correct? On roadside small shop or this one, and even under tree, people are able to service carburetor, brakes, all the emergency, correct? This is not possible, but you would require software engineering, many apart from mechanical engineering, many circuit servicing circuits, because no lot of ECU sensors and software programming, all those things should be possible at the mechanic shop at anywhere in the world. That is another requirement, correct? Autonomous semi trucks, already platooning, we saw that, correct? And farm machineries, correct? Farm sector, correct? Harvesting machine, sprinklers, correct? And tractors, autonomous tractors. Even Mahindra is testing. Indian car company, tractor company is also testing. They are developed already. They are able to demo. It came newspaper, news channel last year also. Correct. Without driver, driver can sit inside his house. He can plow the field, controlling the this one. Combiner, harvesting machines, fruit picking. Correct. All these things are now become fully autonomous. Correct. Vehicles are available. So not only road vehicle, this is there. Okay. So if you want to make autonomous vehicle, what are the needed? You need to have a GPS receiver, correct, to know its position, receiver for localization. We'll see what is localization of vehicle. Localization of vehicle. Without that means, what is localization? The vehicle should be able to find its current location. Find its current location at any given time automatically, right? So if I'm driving from the one city to another city, I know that I wanted to become new. I'm driving from here, I'm going to, for example, Bangalore, correct? In a new road, totally new road, correct? So what I do, I will see the signboards, or the signboards mention what is the place you are going. Then I see shops. Shops, you put the place name, correct? Town name, village name, correct? I read these road signs as well as the shop boards, correct? Which is name boards, all those things. And I can find out. That's what human driver used to do for many years, correct? Even when I do before GPS came. Now with GPS receiver, you will be able to locate where you are. So the same GPS receiver will be used for autonomous car to locate where it is. Correct? It has to start from this location to for example, Salem. Correct? So it should know what is the coordinates of Salem GPS coordinates, and also Chennai coordinate where it is. Correct? So when I say start from here, go to Chennai, I can give voice command, or on Google map I can touch start location, end location, or key in. Once is given, the what you call as a path planning algorithm. The path planning algorithm can always generate map, correct? How it is generates actually it takes path which is available as this one. So Google has already, Google map already we are using a cell phone, correct? So it is a database. Using the database for roads, all these things are available network, correct? Already available, which is captured by Google and put inside the Google Map service. That service can be, it is available in a server that can be accessed using GPS receiver, correct? You can use a GPS receiver and access the Google Map available in the Google server, and using that you can plan your route and make the vehicle to drive, right? Then you need the distance measuring or obstacle ranging sensors, correct? Which is called ranging means, ranging sensor is nothing but you have your vehicle, correct, in front of this an obstacle, right? Obstacle is there, correct? So this is the vehicle can find any obstacle distance between, correct? The obstacle in itself by sending light waves or radio waves, correct? So lidar is using laser, In case of radar, it uses what you call as radio signal. Then camera it can use, correct? You can attach a camera here, correct? A camera to look into the road and detect obstacle. Then you can use ultrasound sensor, correct? These sensors are needed for identifying obstacles, correct? And road signs, right? And also lane markings. These are the main thing for driving a vehicle. That's what driver is doing, correct? We knew that. Apart from that, we need a central computer, because all these things come to a controller, vehicle controller, which needs a data processing and the path planning. Data processing is from vision sensor, radar, all those things. Images are coming, sound waves, reflectors are captured. Using that, it has to process and identify obstacle, lane marking, all those things. Data processing. Then it need to identify the path and correct from the starting location, ending location, and to do path planning. Which road to go? Path planning, nothing but what? For example, as I told again, I take same example. Chennai to Bangalore, there are 2 to 3 different routes. I can go from Chennai, Vellore, Krishnagiri, Hosur, Bangalore. Otherwise, I can go to Vellore, correct? From there, I can Chittoor, Madanapalli, something. There's one more route. There's another one more route. There are 3 routes. If you see a Google map, it shows 3. Which one is shortest? Or which is the best efficient, fuel efficient? Correct? Which is the fastest? You can decide, correct? If you go in a highway, national highway, but you have to pay toll, correct? Toll you have to pay. But road is good, uninterrupted, fast. You can go within 6 or 7 hours or 5 hours, correct? If you take another route, there's no tolls. That means you need not toll fee, but the road is longer or narrow road. You cannot drive faster, correct? So you take 8 hours, but without toll, correct? Other road will mix all those things. So that is called path planning. Find out what are the possible paths and which is best, whether there's a congestion happen, traffic happens, because even highway, there's a road accident, correct? So there may be a vehicle get jammed, correct? So that information now available through Google Map is giving all the information using GPS, where accident happen, all those things. So the path planning, data processing and path planning is done by central computer, correct? That is called a central computer or master computer. And all that finally it has to give commands to the subsystem control. Vehicle control, correct? You have to do vehicle control, correct? Controlling means controlling engine, correct? Steering, correct? And brakes. All those things you need to control, correct? So this control is done by same controller. Of course, it gives the command, but actual control is done by embedded system available in individual subsystem. We are going to see today, correct? Embedded system. Installed in the subsystems, installed in vehicle subsystems. What are vehicle subsystems? Engine, brakes, that is ABS, steering control, correct? Transmission control, that is gear changing, automatic gear, all those things. So each subsystem is, there's a ECU, electronic control unit, which sensors, it controls. So these subsystems, these embedded controllers receive the command from the master controller based on the path plan, all those things, correct? And the driving is done by combined together. The master controller along with the embedded controller in the subsystem. We'll see it subsequently. Then, of course, you need a radar sensor, as I told you that this is for ranging, correct? Then communication, correct? Autonomous vehicle need to share data within the vehicle or between vehicles or between vehicle and infrastructure, correct? Outside. So that for that you need wireless communication. Wired communication, not for the wireless communication is needed, correct? They are called short range communication like Bluetooth, Zigbee, Wi-Fi. These are called as dedicated short range communication, which is used in home appliances also, correct? Which also can be used in an autonomous vehicle. Okay, so this is the okay. Now, as I told you, that when we want to talk about vehicles, inside vehicle there are many things, many subsystems are there. Correct. Those subsystems consist of controllers and sensors. So the data from sensors should go to the individual ECU of the subsystem, and from there it should go to central computer, which is a master controller, which is for autonomous driving. This
picture layout shows a typical layout in a car, advanced car, correct? And there are two types of communication, correct? One is called in-vehicle communication, correct? Inside the vehicle, you have a lot of subsystems like engine, brake, transmission, correct? Steering control, correct? Air conditioner, controlling the body electronics, correct? Safety related, correct? Airbag release, correct? Monitoring the doors, all those things, correct? So then, of course, you may have music, communication systems, and entertainment systems. All those things are there. So most of these are called subsystem, vehicle subsystem or in-vehicle system. In-vehicle system also need to share the data. We will see the why today. For that, you use the what you call wired communication. Very popular communication is called CAN, correct? CAN communication system. CAN communication system, right? It is called, they also called a CAN bus. Correct? It is called CAN bus. It is a wired communication. It is a set of wires used to transfer data from engine to brake system, from brake to steering control, all those things. You can see that they are connected by the wires, correct? Lines. The green line shows, correct? So there are three kind of systems are here. I will tell one thing. One is, you can see that one is green color. All are marked with green color, correct? There are something which is marked in black color, correct? So this is a black color, correct? So the most of things are in the green, correct? You can see. Then few are in the brown, correct? So what are those things? See the one system used for communication, used for transferring data between subsystem and CAN bus. CAN bus is generally a medium speed communication system. Medium speed communication system. Okay. So where the medium speed means, here you will be able to transfer 2 megabits per second. You know, the data is transmitted as a binary numbers, zeros and ones. 1 0 1 0 0 1. So you know that data is always transferred in these are digital buses. Another thing is, most of the buses used in this one is called digital bus. Bus is nothing but a set of wires. We will see what it is, correct? Bus is a set of wires used for transmitting data from one device to another electronic device, correct? Or subsystem. So generally, being digital, they said binary data, correct? Binary data. Binary data is represented by 0 or 1, which is nothing but 0 volts or 5 volts. I told you. They generally on TTL level, correct? They transfer this TTL level signal, transistor logic, 5 volt signal, correct? 0 is represented 0 volts, 1 logic is represented by 5 volts. So all there are three type of communication. One is called medium speed communication, which is represented by CAN bus, correct? CAN bus is connecting the most important system, correct? So you can see here the drivetrain. This is nothing but the engine, correct? This is engine. Drivetrain is nothing but engine. In an automobile, when we have a diesel engine, petrol engine, you need to control depending on accelerator, this one, driver demand. If you press accelerator pedal, vehicles will accelerate from the current speed, and if you take the leg away from, it should decelerate, correct? By pressing the accelerator pedal, pressing or depressing, you are giving command to engine ECU, so that engine will be injected with more fuel, less fuel, so that it can accelerate, generate sufficient torque. So that is done by drivetrain control engine, correct? Then if you want to steer the vehicle, you need a steering control, correct? Then next thing is braking system, correct? Braking system, the central body control, which including braking, correct? So these three are very important, where the data should be should be transferred faster way. You cannot transfer data because you may meet an accident. They called real-time systems, correct? Please note that everything is real-time. Here, in fact, this three engine control, brake control, transmission control, and steering control are called as hard real-time system. Hard real-time system. Hard means we know that soft and hard. correct? So soft means if it works okay, if it doesn't work also, the damage is not much. But hard means it has to work. If it doesn't work, there can be severe consequences, correct? When you apply a brake, correct? When you apply a brake, the ABS should be able to apply brake instantaneously, correct? And stop the vehicle within stopping the other way, accident may happen. But during the time, most please take notes because the key points I'm always saying, correct? When you apply a brake, apart from applying brake, ABS system controlling applying of brakes, correct? Which is on the wheels, correct? Brake, shoes, and the ABS controller. When you apply a brake pedal, the ABS controller also sends a command to engine controller to decelerate, correct? If you are traveling at, say, 70 miles or 60 miles speed, correct, 100 kilometers speed, correct, approximately say, correct. When you go high in the highway, suddenly you see a obstacle in front of you, or somebody trying to cross, pedestrian, or an animal is crossing. What do? You apply a sudden brake, correct. So, for example, the distance between you and the obstacle is say 200 meters. You notice and you apply the brake. So, your vehicle should stop within the 200 meters, otherwise you will make an accident, correct. So, during that time when you apply brake, if you are driving manually, what you will do? First thing is you have to release the accelerator pedal, correct? You will take your foot from the accelerator, you decelerate the vehicle. You should not accelerate by pressing the brake, accelerator pedal, also apply brake together. Then what will happen? Your vehicle will skip, correct? First thing is you have to apply a brake parallelly, simultaneously. You have to reduce the vehicle speed also by taking your leg or decelerating vehicle, correct? So that's what you do. Then if the steering is needed, if you want to avoid this one, the obstacle is very close, you want to, you may steer also. You do, what do? You apply brake pedal. You also remove foot from the accelerator pedal, so the vehicle acceleration reduces simultaneously, and also needed steering. All three will do depending on the situation. This is what the autonomous vehicle has to do, correct? So that means when you press the accelerator pedal, correct? Now you are pressing, but autonomous vehicle, how it does? It sees using ladder or radar, it always finds the obstacle. If it finds the obstacle, first thing what it will do is the brake will be, ABS will be actuated, correct? The master control actuated, and simultaneously the ABS will in turn give a command to the engine, correct? So reduce the acceleration, correct? So that means the data should be transmitted from the command from the ABS. The ECU will be giving command to engine manager, correct? So that command will be sent through communication bus. For that only they are using CAN bus. CAN bus generally can transfer data up to 2 megabits per second, 2 Mbps, correct? So CAN bus can transfer data up to 2 megabits. That is the median speed, correct? Then the green color one is called a LIN bus. You can see that is called LIN, correct? It is called LIN bus. It is a slow speed bus, correct? Here, the maximum data speed is 20 kilobits per second, KBS. See, 22 megabits. 2 megabits means 2 into 10 power 8 bits per second, correct? Will be transmission rate at the CAN bus. In case of LIN bus, generally 20, that means 20 into 10 power 3 bits per second, much slower. That is sufficient. Where it is used, you can see that the LIN bus is used for connecting ECUs of the instrument panel, speedometer, all this. Now it is digital, correct? You have the most of the cars. Then you climate control, AC control, air conditioner control, correct? Lights, correct? Headlamps, or internally you have reading lamps, all those things, correct? Instrument panel, all those things. Then seats, correct? Now if you go 20, 30 lakhs, the heated seat, ventilated seat, automatic seat adjustments, all those things, correct? Then roof, correct? So, for example, sunroof, moon roof may be there. If you spend 15 to 10 to 12 lakhs in most of the cars is there, and you want to control electronic, because so that goes. Then seats, correct? So then heating system, all these things, correct? Window, correct? Trunk opening, all these things, correct? Mirror, correct? Side mirrors, both sides have side mirrors. All these things are controlled. Now, side mirror, headlamp, air conditioner, moon roof, sun roof, all these things are connected by LIN bus, correct? So LIN bus is another bus. Please note, a bus is nothing but set of wires. These are wired coming. We are going to see each one separately. What is a CAN bus, how it works, how LIN bus works, all those things. It is only introduction we are trying to talk, correct? Then third one is, you can see that it is in the shown in this one, brown color, dark brown color, which is nothing but digital radio, vehicle computer, navigation, GPS, all those things. the music system, speakers, CD-ROM, all those things. Of course, you may have a TV, correct? Cell phone, all these things are connected. For that, they use what you call as a most bus, MOST, correct? Most bus. Most bus is much, much higher, where the data transmission is up to 50 megabits, Mbps, right? 50 to 100, correct? Which is 5 to 10 times faster than the CAN bus. So these are called wired bus or internal buses, correct? So you can see that this is in-vehicle communication, correct? Transferring data between the electronic control units of engine controller, ABS, transmission system, steering controller, music system, mirror, lamps, all those things, correct? Then door, correct? So if your door is open, you can say if you don't wear the seat belt, correct? Engine won't start, correct? It will give a beep and it won't start, correct? They are then the doors. If your doors are open, if you didn't close properly, any of the door or boot is not closed, correct? So the vehicle will not start, correct? It can lead to accident. People come falling out of because door suddenly open, it can make an accident. So although all these things are connected by low speed communication, LIN bus, correct? Engine, brakes, steering. These are life threatening, correct? If it doesn't work, so they were used with CAN bus. But then most bus is still higher speed, correct? And that is meant for where high data the transmission rate is, as per more data, correct? Video signal, all these things. Communication, entertainment, all these things, huge amount of from CD-ROM, GPS, correct? All these things, GSM, cell phones, correct? You may get, you want to watch a movie in your cell phone, all those things can be connected digitally, correct? For that, they use most bus. These are called in-vehicle communication, they are wired communication. Then so again, this picture shows a little more clearly, correct? So same thing only you can see here. Engine, high speed communication. I told you the median speed, even 2 megabits per second is generally high speed compared to LIN bus, which is 20 kilobytes. So you can see that diagnostics, engine, transmission, suspension, and brakes, of course, brake control and steering. All these things are done using CAN bus, high speed, correct? Still much higher speed is most bus. Most bus is radio, navigation, correct? Music system, all those things are controlled by high speed, correct? Which is by most bus, which is 50 to 100 megabits per second. Then all others are controlled by low speed, correct? Windows, mirrors, air conditioner, instrument cluster, speedometer, all those things, lighting system, all these things are done by side mirrors, all these things by low speed bus, LIN bus. Or there's now one more thing also called low speed CAN bus, correct? In CAN bus there are two things. Originally CAN 1.0 long before. When we talk about CAN bus, I'll tell you it is a low speed where the data transmission only 1 megabits maximum, 1 Mbps maximum. It was introduced by the Bosch Electronics, no? Bosch company. So it is considered low speed because generally they transfer to 500 kilobits per second. Maximum is CAN 1.0 is 1 megabits per second maximum. Normally it's 500 kilobits. So it is called low speed CAN. CAN 2.0, which was released some 10 years before, correct? Now we have another version which can go to 8 megabits also. This is called high speed scan. Correct. High speed scan is used for engine connecting, engine control, engine transmission, correct, and ABS and steering controllers. This is very, very important. When you apply brake, the vehicle should stop. When you accelerate, vehicle should accelerate. Correct. When you want to change gear, it should change. Correct. When you steer, you wanted to change lane. Correct. Lane change. So data transmission should be faster. There should not be any delay. So they use high speed CAN, which is 2.0. Here, the 2 Mbps. The low speed CAN is around 1 maximum 500 kilobit that is used for internal, or they use LIN bus. LIN bus is 20 kilobit. That's what we use. Correct. This is called in-vehicle communication. The other one is, so when we say, okay, now we show the block diagram here. It is given as a bulleted points. Correct. In-vehicle communication used in correct communication buses or bus systems. The very, very old one is called RS-232, correct? No, even in a computer, you will see that, correct? Printers, mouse, correct? And then old this one electronic gadgets, correct? Or microprocessor, embedded controllers, all those things use what we call RS-232 communication, which is called the asynchronous communication, correct? You will see in the behind your computer, you will see a D connector, something like that, correct? There will be a 9-pin connector because like this, or a bigger or old computer will see a 25-pin connector, right? So it is called, it looks like a D, correct? So they call D connector. They call it COM port. If you see that in computer, even now, you go to Windows, they say COM port. COM port is nothing but RS-232 communication, where the maximum data transmission is 19,600 bars per second, and maximum distance you can transfer to. It is a wired communication, correct? So it is used for transferring data between two computers or mouse or any other this one. So it is 9,600 bars or 19.6 kilobits per second. That is maximum speed. It is a low speed communication. This is there for last 60 years, more than 60 years. Still it is in use. Low speed communication. Then next came RS-432 communication system, which is called differential signal. This one, which can transmit data up to 10 megabits per second. It is same as RS-232. This one, it is a serial communication, two-wire system, right? And it can transmit data up to 10 megabits. Here you can see the 19.6 kilobits KB, RS-232. RS-432 is an improved version of RS-232, which uses a differential signal. I will say what it is, and it can transmit data up to 10 megabits per second. And here you can see that only 50 feet is allowed in RS-232. In case of asynchronous communication, RS-432, the length of the wire, because you have a system here, I say S1 and S2, two systems are connected by a wire. If the RS-232, see, old this one, we know that the maximum length is only 50 feet. This wire length cannot be 50 feet. In case of RS-432, 422, correct? Which is again asynchronous communication to 2 wires, but you have different signal. Here it is 10 megabits per second and 1,500 meter. You see 1.5 kilometer can be length. Between the distance between two wires can be 1.5 kilometer or meters. Then next popular came is CAN bus, controller area network. The short form is CAN, right? It is a high speed bus compared to what? Compared to the RS-232, correct? RS-232 is the slow speed again, right? It is all serial bus. So here it can go 1 megabits per second. This is CAN 1.0, correct? In case of CAN 2.0, it can go to 2 megabits per second, correct? High. Then you have another LIN bus, I told you. It is called local interconnect network. That is short form is LIN, L-I-N. The full expansion is local interconnect network. It is this, it can transfer up to 40 megabits. Sorry, I said 20. It started with 20 because the version 1.0, 2.0 it came. The latest version supposed to, the original version of 20 kilobits. Okay, no problem. It can go up to, but still it is a low speed compared to CAN bus or RS-422. Correct. Then the most popular this is, I told you, MOST bus. MOST bus called media oriented system transport. Short form is MOST bus. It is a high speed bus where 10 megabits, it can go up to 50 megabits of the latest. 50 to 100 megabits per second is possible. Correct. Originally it was 10 megabits. Now it has gone into this one. So these are the most popular. Correct. These two are not used inside the vehicle. In automobiles, initially before the CAN invention of CAN, local and MOST bus, they were using RS-232 and RS-422 even inside the car in 1960s, 70s and all. Correct. Once the CAN bus came introduced by, it was invented by Bosch company. Now it is available for anybody to use it. They released for public use. CAN bus came, then these are not in use for vehicles. Now these three are available: CAN bus, LIN bus, and MOST bus. These three are most widely used inside the vehicle. Okay. So that is wired communication. Other one is wireless communication. Correct. Wireless communication, that means because vehicle is moving, since vehicle is moving, you cannot connect wire using wires to share the data outside world between a vehicle and another vehicle, between a vehicle and roadside infrastructures or signal. This one, traffic signals or pedestrian, correct? Or you wanted to get the data from your cell phone data or GPS data, all those things, then cloud, of course, all these things should be connected wirelessly, correct? It should be connected using wireless communication systems, correct? Outside world, correct? So what are most popular communication system, wireless communication system used? The licensed wireless communication, correct, is called cellular network, cell phone, correct? You can use cell phone signal, correct? Same SIM card you can use inside the vehicle for transferring data from the vehicle to outside. So cellular network, then WiMAX, wide area, WiMAX, another communication bus. But these two are classified as licensed radio. Why? You need to pay, correct? Cell phone, that's why you are paying, correct? Cell phone we call a spectrum, correct? The spectrum used for cell phone is auctioned by the government of the particular country, Indian government auction. So that is bought by BSNL, Vodafone, Airtel, correct? Zio. These companies paid huge amount to use the wireless spectrum in particular area. Correct? You know that auctions were given by government. They say then we pay the cell phone companies to use the spectrum to so that your cell phone you can talk, your voice and video can be transmitted. So they are paid services. WiMAX also you have to pay. Correct? Does it mean that there are free radio communication? Yes. That's why I said license communication you have to pay the fee. Correct? To government or the company which is owning the spectrum. Correct? Cell phone generally owned by BSNL is the government. There are many Indian companies, Airtel, Bharat, all this thing, Zio, Vodafone, many companies. So you have to pay. That is license communication. Then another one is called license free. Right? License free communication. What are systems? ZigBee, Wi-Fi, Bluetooth, 6LoW, WPAN, and Z-Wave. These are the few most widely used license free radio communication in automobiles. ZigBee, Wi-Fi, Bluetooth, correct? 6LoW, WPAN, all those things. Then within office space also, correct? Inside the office also we are working. So we need not worry. Inside we are using LAN, correct? And wireless communication, wireless LAN, Wi-Fi we are using, correct? And of course, the vehicle when you transfer microwaves, DSL, satellite phones, cellular phones, correct? Sometimes because you are traveling in a vehicle, you want to use your cell phone, correct? So cell phone, so your cellular communication, you can use satellite communication. That is a special, you have to get government permission. It is a wireless communication, DSL, micro, all those things you can use. These are wireless communication system, correct? Used to we are going to see this 4 to 5 hours about these things separately. How ZigBee works, how the data is Wi-Fi, Bluetooth, all those things. Right? So the self-driving, as I told that self-driving cars, the autonomous vehicle, road vehicle, this is called sensing and it has to do, it uses a wide range of sensors. It needs a data processing and control unit, correct? Then it has to generate control signal to control the engine, steering, transmission, brakes, and other subsystems so that vehicle can be driven safely, correct? And this is the talk. Now, what is future for this autonomous vehicle, correct? Already they say that 10 million autonomous vehicle will hit the road by year 2020. This was estimated as some 4 years before, 3 years before. I think 2018 or 2019, correct? 10 million, but that much it did not happen because of Corona, all those things, you know, that 2020 was complete lockdown. Of course, to my knowledge, already Tesla sold 5 lakh cars, 500,000 cars or more, right? Already hit roads in 2020 itself. But of course, because of Corona was done, definitely they would have sold more. In 10 years, fully autonomous vehicle will be normal in many of the roads around the world. But that means by 2030, correct? You will see around 10 to 15 or 20% of vehicle autonomous cars around the world. I'm not talking India alone. Europe, Japan, Korea, Asian countries, US, Canada, correct? South American, they expect around 20 to 30%, even more also. correct? We don't, that depends upon the economy, paying power of the consumers, correct? Because autonomous car, you put lot of other cost, you know that Tesla car costs around 70 lakhs in India, rupees 70 lakhs, right? So it is highly expensive. And they say that this is only one car is selling. And all car companies are now doing this to come out. An autonomous vehicle will generate 7 trillion annual revenue by 2050. Of course, 40 years far away. See the number 7 trillion, correct? They say by 2050, most of the vehicle will be autonomous, including truck, everything, and will be electric. It is expected that most of the automobiles will be electric, including truck, bus, car, all those things by 2040. Correct? 2040, they say most of the vehicle, most of the 90% or more than that will be electric vehicles. Correct? And then in this case, the generated revenue will be 7 trillion. This is far away, but it's widespread autonomous vehicle will lead to 90% reduction in road accidents. Still, few accidents can happen due to failure of sensors, all those things. That is much lesser compared to human error. Okay. Then what about loss? Because at present, only few companies are allowing autonomous vehicle to be driven in the road. Correct. So we are talking US federal regulations of the autonomous vehicle, National Highway Traffic Safety and Administration. Correct. Which is called as NSTSA, like NHA, National Highway Authority of India. Similar to that, in US, it is called as National Highway Traffic Safety Administration, NSTSA, correct, which controls the transportation departments, specifically the minimum performance requirement, correct, of the motor vehicle equipment certificate can before selling, correct. What is the level? We know that level 0, level 1, level 2. At least they say that it should be level 4 or cross level 3, autonomous. Level 3 or level 4, autonomous as per SAE standards. Already told you. Correct? It should have every sensors, all those things that we tested, qualified. Those vehicles can be driven in the highways. Right? Autonomous vehicles, some highly autonomous vehicles could not meet the federal requirement of safety standards, which is called FMVSS. Correct? Federal Motor Vehicle Safety Standard in US is called FMVSS. If this I am talking 2 years before, because this course I'm teaching for this is 3rd year. Right? That time it was not there. Now it has been now. That's why Tesla is able to sell in India, US, everywhere. Correct? And NTSA can approve limited number of exemption from this one. This again, I told you, 2019 or 2000. Correct? That time, limited vehicle only allowed Nevada, California states, and with special control. Tesla were doing like that, selling and testing with the engineers on board. NTSA can also approve imported autonomous vehicle that can do FMC. It is in US, so maybe Japanese car, German car, BMW, Mercedes-Benz, or Ferrari, all those things are, for example, Lexus, correct, can be sold. I am talking of federal rules in 1918 and 1990, correct? So guidance were identified, correct? What are those things which is when what should be there in a car which is then will be identified as a level 3 car or level 4? Safety system should be there, operational design domain, object and event detection, correct, response, fallback, minimal risk. Suppose something fails, still vehicle should be able to safely drive and stop somewhere without hitting anybody, correct, fallback or minimal risk condition, validation methods, human made decision. Suppose the autonomous vehicle, something fails, whether there's a provision for the driver to take over, correct. There's to mechanical brake, all those things. We are going to see that brake is there, ABS, drive-by-wire is there, and a regular brake, which is also ABS. Correct? Steering control, drive-by-wire steering or ordinary steering, all those things. If it is drive-by-wire, if something fails, you cannot drive. Or steering, drive-by-steer means you cannot do it. All those things need to be controlled. So the manual provision should be there. Then only they are allowing. Then cyber security, data is transmitted wirelessly between vehicle, all those things. Somebody rogue attacker. So we know that virus they create, all this and attack this one, cyber crime. That means sufficient security should be there in the software implemented in vehicles. Correct? Crashworthiness, post-road crash behavior. Correct? Data recording. Because if you know that if aircraft makes an accident, they take a black box and find out which sensor, because send all the engine aileron, whatever the engine, aircraft subsystem data are recorded, and what pilot talks with the air traffic control also recorded. Those things should be recorded. Same thing they want. Some amount of recording data, and for the later recover the data and do the investigation. Then consumer education and then following federal and state law, correct? So these are needed. Recommend that the entities use ADAS testing development demonstrate that at least 12 safety elements by public and voluntary. So these conditions should be met. Okay, these 12 should be met. Then only those vehicles will be allowed in US to drive autonomously. That was achieved by Tesla and Google car. And of course, new companies also coming. These are Google cars are fully autonomous. That is level 3 or level 4. Right? Other companies are coming there. Federal regulation, we saw that up to these are last. Okay. So there are 23 states under district where the US capital, Columbia is nothing but Washington, correct? District of Columbia is located. They allow, these are the states. Then additional states were also trying to follow that. California, all these things are these states, because this is US. Because this one I took in 2018-19. Okay. So tell me near autonomous cars, already I told you that this will be the future. Right? And yeah, thank you. I stop this. Next class, what I'm going to do is we are going to start about the individual subsystem like engine control, brake control, steering control, and transmission control. Apart from other things, should be made electronically controllable. Then only autonomous vehicle can be controlled by master controller. These are called vehicle subsystem. We will start that tomorrow. Okay, I stop here. See you tomorrow. Thank you.